So the original plan was to grow um, apple seedlings or apple from seed for 14 weeks, 12 weeks, and 10 weeks. And for the 14-week phase, we also seeded them in a closed wall tray that only had an irrigation hole on the bottom for air pruning. However, the trial kind of changed quite a bit. A lot of the seeds were ready at week 13. So the modified trial that we were looking at is looking at trees that were growing for 14 weeks, 13 weeks, and for the 14-week trial, we compared the Root Smart tray, which is more open and allows for air pruning to occur, to a more conventional closed wall tray, where we're calling it the cone tray, where it just has its irrigation hole on the bottom, and that's really the only kind of air exposure that that seedling would face to. So it's looking at an open system versus a closed system. And today I'll be going over and showing you some of the pictures of what we found out, how this trial worked out. But I do want to say this is the trial in current operation, and these are the 14 weeks seedlings. And they grew really well, really quickly. They may be too big for planting, so that's why we're hoping to eventually kind of look at these seedlings on the bottom that were planted much later, because we want the stalk quite a bit smaller than that. So when they're going out into our farm, it's easier to transplant. But today I'll just be focusing on the 14 and 13-week study, and we can discuss how we want to move forward from what we learned from this trial and kind of look at optimizing for the next cycle, for the next field season. So we were very excited to see the results from this. So I wanted to share just a few pictures. So this is the cone walled tray. So this cell is completely walled off by plastic, and you can see only the irrigation holes on the bottom, whereas for the Root Smart tray or the open tray, like Darby said, it has kind of air exposure all around. So I'm going to go over the results that was talked about in Darby's presentation, where it looks at how air exposure really promotes that lateral root growth. And when you don't have that air exposure in correct locations on the cell, this is when you start getting deflected roots, which we started seeing a lot of this with the cone walled tray. So the cone walled and the Root Smart were grown for 14 weeks, but then we had an additional kind of treatment where it was just 13 weeks old. So although these trees are the differences in sizes, there was still some variation within the stalk sizes. So this is just kind of showing you one set, but there were a lot that were similar heights, similar roots, sizes. So this is kind of, it's a misleading photo, but it's just to show you kind of the different qualities and roots that we were really observing. So what we did was we took a few and destructively harvested a bunch, where we wanted just to remove all the media from it and then look at where the roots were growing and how well they were doing, and essentially indicate how well they will do once they're out planted. So these are the same trees that I photographed in the first slide, and these are just them root washed. So you can see here, there's a lot more fine root material that is really will take off once outplanted. I'll show you closer pictures of them and to explain what was actually occurring with them. This is a cone walled tray, and what it really had was not as many fine roots, but long, fatter roots. And I'll explain why this was occurring, but they were having a lot of roots, and a lot of roots that were fat and directed downwards. So what Darby said in her presentation was the initial radical root that emerges from the seed, it is going to be oriented downwards and kind of go down the tray until it hits something where it can't stop growing. And for these trays, this is the air. So for the cone tray, the irrigation hole kind of acts as the air pruning termination point. And so you can see here with these root tips that are going, once those have hit the air exposure, that root is going to stop growing and it's going to send hormones up through those roots and start sending those lateral roots out. Although it's really hard to see from this picture, I do promise you there was a root that did hit the bottom and it had the same process. So both seeds produced these radicals that were directed downwards and eventually terminated pretty much at the same spot. Now, where the differences lie is where the next roots come out and how they interface with the tray itself. So I want to start and talk about the cone-walled tray. So you can see here, because this has a closed side systems, when these roots terminate, those side roots kind of don't have a spot to go. So when I was initially saying that terminal root grows down, it hits the bottom, and now it's going to start sending those lateral roots out. But what happens when you're looking at a closed wall tray is when those lateral roots are growing out, it's going to hit the plastic wall. And because it's not terminating, because it's not having any air exposure, that root can actually stay within the cell and it's going to go somewhere else. What we saw with this tray is that it actually would hit the cell wall and then get directed downwards. And this is why you're seeing a lot of these roots just forming really at the bottom and not really much at the top, but these roots are just very long and stringy. And that's why once those roots start growing, they'll just continue growing downwards, and it's not really producing that many fine roots that the tree will need when it's outplanted to collect nutrients, water, and all the resources it needs. Whereas when we're looking at it, the same type of procedure, which happened in the open-walled tray, you can see that radical root grows down and it terminates at the bottom. And now what's going to happen is it's going to start sending out these lateral roots. And what's going to happen is once those are exposed to air, that growth is going to terminate, and it's just going to keep sending lateral roots further up the root ball, pushing out a lot of these kind of fine, nice roots that once outplanted can kind of continue exploring the soil. And the one thing that we like to explain what these roots typically go for in perfect conditions is they kind of look like a fishbone system where you have these rib cages kind of acting like these lateral roots. And you can see with this picture right here that because these trees were grown, the taproot has kind of gone down here. It's really sent out a lot of these lateral roots because it's continuously air pruning. And it's continuously allowing roots to stop growing, and then it's telling that main root system to send more roots out. And it's kind of a continuous feedback where more and more lateral roots are growing out. And what's good about this is that this is a very fibrous root ball, and it's really ready to go for outplanting. One of the big things I do want to talk about, especially for root management for these open-walled systems, is although the technology is there for watering, or although a lot of trees can be out there which promote air pruning, this technology will allow air pruning to occur, but it really needs to be focused and paired with your water management too. And this is what Charlene's going to be talking about in her presentation.